Welcome to the Panda Consulting Workshops. Panda Consulting is an ESRI cornerstone business partner with over 20 years experience specializing in land records, parcels, and the parcel fabric. We have received both the state and local government and the release-ready specialty designations. We provide an array of professional services including comprehensive planning, design, mapping, maintenance, remapping, implementation, and training services, and hope you contact us so we can help you with your next project.
Now, let's enjoy the workshop.
Welcome. This is Frank Conkling, and this is Panda Consulting's ArcGIS workshop. And for this workshop, we're going to be exploring the Arcade Intersect functionality inside of ArcGIS Pro. Now, this isn't specific to parcel fabrics, which is what we're usually talking about, but it is anything inside of ArcGIS Pro can utilize this functionality. And interestingly, this is one of the many components of Arcade that I find just fascinating because they are building into this scripting language an ability to go and do things that previously we'd have to run separate geoprocessing tools to go and do. And it's everything from calculating information as it relates to intersections between various layers inside of our map or inside of our data store, to calculating the values, to modifying labeling and pop-ups. And Arcade has become sort of the de facto language, the scripting language for the new technology that Esri has put out there. And Arcade works in ArcGIS Pro, it works in Enterprise, it works on published services on ArcGIS Online, it works in field maps, it works all over the newer technology. It does not work, however, in ArcMap. So just be aware of that. And it's another reason for you to go and seriously begin moving and transitioning into ArcMap. So what I wanted to do is focus on this workshop on the Intersect function. And this function really, all it really does is it looks at using Arcade. It allows us to go and intersect two different geometries. Similar to what we used to do with unions, it would go and intersect two different geometries, and it would return either just a Boolean answer saying yes or no, it does intersect, or it would return a feature set of collections of things that actually are being intersected. And if you look down here on the bottom, it will actually show you in the illustration what it can intersect: points on points, points on lines, points in polygons, lines on points, and points in polygons. So it intersects all of these things in here when it's going in. They've got some really good code here. There's also some great blog posts on how to go and utilize this. What I'm going to do is I'm going to go and illustrate a simple intersect script, and I'm going to walk you through every single one of these components so you understand what's really being done. And especially if you're new to Arcade, it's going to look a little different, but we're going to walk you through it. And then we're going to show how you can utilize this. You can utilize it for labels, for calculations of attribute fields, for all sorts of things. All right. So again, that intersection function can be used for calculation of attributes, for labeling, for pop-up expressions, all different components in here. And again, it can be used against all of the new technology that Esri has. So this is the gist of it. And again, don't let this scare you away. We're going to walk you through every single line here. So the first thing we're going to look at is this var. This is a statement that you wish to go and create a variable in which you're going to store things. So in this case, I'm going to create a variable called buff, which is going to go and be a buffer around our individual elements that we're intersecting. In this case, we're going to be intersecting polygons. You see here is subdivision polygons over here, but we're going to intersect polygons. And what it's going to do is going to take every single feature, and this $ feature is the arcade code to say evaluate every single feature. And it's going to go and create a buffer that's located just inside the boundary of that polygon. And it's going to be 0.001 feet. It's going to create a buffer that it's going to analyze. So that variable sets up this buffer. So if I want to go further outside or if I want to go further inside, all I really need to do is change this distance here, and I can make the buffer wider or smaller, depending again on what I want to do. The next variable I'm going to do is I'm going to create a variable called Intersect layer. This is going to return to me what's called a feature set. This is going to be a collection of features that actually intersect. And here's my function. This is the one that's doing all of the work. This is the Intersect function. And it's going to go and intersect a feature set by name. This is the way you reference a layer inside your data store or inside your map document. Now, again, I then use a global variable that says, I'm looking into my data store, which can be file geodatabase, can be an enterprise geodatabase. It can be services that are all part of that service that's being published out there. But it's a collection of data that's been defined as a data store. And then in this case, we're going to look at one whose name, not alias, but name is subdivisions. And that we're going to change that around a couple times here. And then we're going to intersect it, and it's going to buffer it by the variable that we stored in buffer. So we're setting everything up right now. The next variable that we go and create is int count. The number of times, or the number of features is how I should actually say it. The number of features that it collected when it performed that intersect on Intersect layer. It's going to tell us how many of them we did. How many of them we did. When we go and intersect every polygon and say intersect against this other layer, it's going to tell us how many times it did it. We're going to set up one final variable here, and this is going to be our expression. This is going to be what gets returned to us, either for our calculations or for our labels or whatever. And I'm just creating a string that's got nothing in it at the moment. So here's where we start doing some work. This next component says, if my intersect count is equal to 0, again, this is arcade, is equal to, if it's equal to 0, then just go and make that a single space and then return it. And you see down here, this is at the very bottom, return that expression. Else, if it's more than that, if it's at least one thing that's been intersected, I want to go through and for every one of the intersects inside that intersect layer, go and calculate the attribute value equal to, and this is our other setup, the value that's stored in this field. In this case, the subdivision has a field called parcel_ID, and it's going to pull that parcel_ID out, and it's going to go and put it into my variable called express, and then I'm going to go and return that. So if I intersect against a subdivision, it's going to go and intersect that, find that subdivision, pull out the attributes that are stored in this field, and it's going to return that to me so that I can go and store that in my features. So let's see if we can actually do this. All right. This is a parcel fabric. It doesn't have to be, but this is a parcel fabric here. And I've got a couple things turned on. I have subdivisions here. This is my current subdivision. And if I look, here's my attribute table. In this case, there's actually 5,000 subdivisions in here. and I have something called name here. And depending upon what I want to go and calculate, this is going to go and it can pull this thing out. The next thing I have is I have lots, and I've turned them off only because I just want to do an intersect of my tax parcel and find out whether it actually has the correct component in there. So just to show you here, I've got the attribute table, and it turns out that I'm going to go and use this test field. The test field, if I hover over that, tells me this is a text string, all right, and it's 255 characters long. So I should be able to store anything that I possibly can in here. All right, so I want to go and use this test here, and I'm going to create an intersect calculation expression that's going to intersect each of these parcel polygons against the subdivisions and determine whether or not it exists in there. So let's zoom out a little bit and see. Let's make sure that these subdivisions, I'm gonna go and simplify their symbology here. Let's turn off the sections. Let's turn off townships, easements, mineral rights. Let's go to symbology and go over here, and let's just make it a single symbol. And let's create this. So this is a big wide one. Let's use some standardized symbology here. And there it is. I suspect that I've got an appearance transition here. Yeah. Let's turn this to 0. All right. So there we can see the overall subdivision polygons. What we're going to be intersecting on here. I can see there's some areas where there's no intersections. There's other areas where there's some definite intersections in here. Let's go and test this initially on just a couple of parcels. By the way, I do remind you, if you have any questions or any comments, please put them in the chat window. Chris is actually going and moderating it. So if you have any questions or want me to show you something, go ahead and include it in there. All right. So what I'm going to do is I'm going to take a couple of parcels and I'm going to unselect. I'm only going to select the parcels. And I can see here that I have 5 parcels selected. And what I'm going to do is I'm going to first calculate. I'm going to calculate what subdivision these things lie inside of by doing this. And again, normally I would do maybe a spatial join, or maybe I would do a union or an intersect to go and calculate that. Here is my table that I'm going to calculate against. Here's the attribute field I'm going to do it. I'm going to change this to arcade. I'm also going to cheat. I'm going to load that expression again. All right. I'm going to load that expression and I'm going to go and make the modifications to it. The first thing is, what's the actual name of that layer that I'm going to be intersecting? Turns out that it's subdivision polygon, I believe. And I can go and validate this when I'm done and let Arcade tell me whether I've got it correct or not. I also remember that this subdivision name field was not called parcel ID, but was called name. So I can go here and validate it and say, oh, it's not subdivision polygon, polygons maybe. All right, let's go and check this again. Oh, let's go and see what the actual properties are here. So our source, it is called subdivisions. So even though in our table of contents, it said subdivision polygons, the actual name here is subdivisions. Let me go and check this. And sure enough, it is correct now. One of the really nice things about Arcade is that it will tell you before you do this, what might be a problem here and where you might want to go in and look at it and evaluate it. So this is real simple. I can go ahead and run this. So let's go ahead and go over here and we can apply this and watch it run. And that's just going and running and doing this calculation. And again, it's taking every one of these, intersecting it with the subdivision polygon, and going to go and give us the answer inside of the test attribute field. Any questions on here yet?
None in the chat.
Okay, so one of the things you may have noticed is that it took it a little bit of time to do this. And
We do have one question, Frank. Do we have
Yes.
these codes available as snippets on our site?
we don't have them on the site, but we can make them available on here. As you saw on here, this is how much I use Arcade. I've got all of these little cheats, for example, how do you do a bearing intersection, or how do you calculate the acreage, or if I'm going and capturing the texturing in an annotation feature class, how do I go and do that? This is a really interesting thing we're doing with the parcel fabric and annotation, and that we're looking to take annotation, capture those values, and put them into a line feature class. And I may demonstrate that later. But anyway, we can make these available on here if anybody really wants them. The other thing is send us an email. We'll make sure that we go and send it to you. All right. So here's this here. Again, it's pretty simple. Let's go ahead and let's go back to edits. Let's go and clear this out on here. Let's go in and create a new polygon just so that we can check and see if this works against something new. So let's go and create. Let me get this out of the way here. Let's go and create a new tax parcel here. I'm just creating a simple little polygon feature class, and I can run this against that test. By the way, here's the values in the polygon that I just created. Let's go ahead and run it against there and see. It still tells me that this is in that same subdivision. Let's go and move over to someplace where there is no subdivision in here. All right, let's go and create something out here in the lake. All right, so I've got it created. Let's go ahead and apply this and see if it calculates anything in here. And in fact, it calculated the value here. It looks like there might be something underneath here where they may actually store some sort of subdivision value in there. I'm going to try and find some place where they don't have something. All right, they have nothing here. Let's go ahead and calculate this. And sure enough, it returned just a space in here, which is what this thing says it should do. We could also tell it not in a subdivision and have it go and calculate that. And when we go and do that, oh, sorry, that's not the place I should have done it. You can tell that none of this is rehearsed, which is what I hope you like about it. It's actually, I should have done it here. I put it up here where I had initialized my variable. Let's make it a little bit there. There we go. Okay, now let's go and calculate. There you go. And you can see that, again, this was down here. This is if there's an intersection and subdivision. This is if my count is equal to 0. It's not an intersection. So I can do anything I want with that in there. So really simple, sort of, okay, that's a good way to calculate something on here. Well, what happens if I want to go and, for example, let me go back here.
Frank, we have another question in the chat.
Yes.
So if we create a bunch of parcels in a subdivision and we wanted to auto-populate the names of that sub into the parcels, we could use this arcade to populate the names of the subdivision or any other intersecting features, say str.
Who asked that question?
Amanda?
Was it Amanda? Yes. Yes. Very, very observant. Let's go and rebuild that. Sorry. So this is subdivisions. This is name here. This is not in a subdivision. All right. Yeah.
Mark
So
wants to know if there's any easy way to convert Python script to arcade.
no,
He says, I would like to run a calculation on edits, but they're currently in Python code.
no, unfortunately, there's no direct translation between the two. There's some similarities in the code, but there's some differences that prevent you from doing that. All right. Unfortunately, sorry about that, Mark. All right. So here's my code again that I've got. And I'm going to go and copy that code because now I'm going to show Amanda what she can do, where I can go to my tax parcel polygon. And in here, I'm going to go to my design and I'm going to create an attribute field. Now, an attribute field, excuse me, an attribute record, wow, an attribute rule, sorry, an attribute rule. An attribute rule can be one of three different types. It can be a calculation where whenever I do something, it calculates this. It can be a constraint where the rule would actually stop me from going and creating something if it doesn't match the criteria that I put in here. And both of these are immediate, whereas the validation rule is sort of like a topology rule. It goes and works against existing features. So in this case, I'm going to go and create a new rule. And let's just call this a test rule. And this is going to work against the test field. And the code that I'm putting in here is this exact same code. I can test it. It is valid. It's good. Now, when I zoom down, I'm going to tell it when to run this code. And I can tell it run the code when I create something or when I modify something on here. Once I'm done with that, let me go back here and discard the changes that I made so that I can actually save this rule. And while this is saving, I see that Lee has a question. The current code is using data store. It requires that the data layer be used is inside the same database, correct? Yes. How do we calculate from two different data sources for two layers? The two data sources, it can be two different data sources within the same workspace. And that is important. It is a workspace. It's not necessarily the geodatabase. If you're making a reference instead of the data store to a map, where you can see layers that are in a map, for example, with ArcGIS Online for expressions, you would, instead of using the global data store, you would use the global $ map. So I've now got an attribute rule. Again, this attribute rule is going to go and calculate this test field equal to whatever subdivision it goes and intersects. So let's go back over here to a subdivision and go in here and actually just create a polygon. All right, create a polygon. This is a tax parcel polygon. And there's the subdivision that it went and calculated. Let's go over to another one, the one that looks a little bit more like a subdivision. Here's a subdivision here. When I go and calculate that, here's the name of the subdivision it's automatically in. So Amanda says, can you use attribute rules to calculate the geometry attributes? If so, how do you specify the decimal places and unit types? Say the acreage to 2 decimal places. Thank you, Amanda. Good questions. So let's go and so we did see this is working, right? All right, so let's go and discard those couple that I just created. And let's go over to attribute rules again. And this time we're going to create a new attribute rule that's going to calculate the acreage. And it's going to calculate the acreage inside of, we have the stated area. Let's use the stated area field. And it's going to calculate it using arcade functions. We can, by the way, because I know that this is in square feet, I can just calculate it being equal to square feet divided by 43,560. But I want to show you a couple things first. So area, $ feature, and then I want it to be acres. All right. That literally is all we have to do. We can tell it we want you to calculate the geometry, the area geometry of each of these features that we create. And we want you to return the acreage function on there. And we want to do that when we create it and when we modify it or change it. This is first, how do you calculate that value? Now, if this was a string value, I would tell it to go and round it into 2 decimal places. Okay.
Frank, Amanda
This-
wants to know if you can show that again,
I
just the
will.
code.
I will. I'll wait for this to apply. One thing you will find is that attribute rules, because they're actually stored in the they are stored in the geodatabase. They're not stored in a project. They're actually stored in the database. They sometimes take a while to go and store and to modify. So again, the code to calculate the area is you're using not an intersect function for Arcade, you're using an area function. And you want it for every one of the $ features, everything that you create, to return the value in acres. All right. There's other things. You could return it in hectares. You could return it in square feet. There's a lot of different units that you can return it in, but it's going to return whatever value you tell it to go and do there. All right. So let's look at how this actually works. So I'm going to go in here now again, and I'm going to go and create a new polygon here. And it should do 2 things when I finish. It should intersect the subdivision layer and tell me what subdivision this is located in. And then it should also go and tell me whether or not, and it should calculate the stated area. So let's go ahead and do that. So here's the subdivision in which it's located, and here's the stated area in which it's located. Now, the 2 decimal places is really not a function of Arcade. It's more a function of the configuration for this data. So let me go here and I'm going to go to design again, but this time I'm not going to do an Arcade rule. I'm going to go to fields, and on here is the stated area field. And if I look across, it is a number field. That's one reason why I didn't go and round it to 2, because it's just going to give me and return whatever the value is in numeric value here. And this is very interesting in that ArcGIS Pro is sort of like ArcMap parcel fabric in that when it stores things like area and the COGO information, those are not stored as string values. Those are stored as numeric values so that the software can do calculations against them. So let me go and show you here on the configuration. See here, there we go. On the configuration, I'm telling it that I want it to return a number. I want it to be 2 decimal places. I want it to be right aligned, showing decimal separators and 0. And if I really wanted to, I could go down here and tell it, put a suffix on this, make it acreage every single time. So now when I do this, all right, and let me go back here and go to my edits, get rid of those, go back here because I've made a change here. Let's save this change. All right, now let's go in here. Let's create another parcel, right? And note, here's the acreage. Here's the stated area, returning to me 2 decimal places, and it's got a suffix on it of AC. Doesn't store the AC in there. It only stores, well, it stores the whole numeric value, but it only returns to me the 2 decimal places. And those of us that are in Florida, this is one of the problems that we have with the parcel fabric and what Esri has done with this, because when we submit our data to the Department of Revenue is looking for string values, not numeric values on here. And when you return it to them, it returns the whole, I think it's 6 or 9 different decimal places out there. And the DOR is actually pinging that and saying, no, that you're carrying it out to too many places. That's not realistic. And we're trying to educate them and let them know, no, that's not us. That's the fact that the way the software has now been modified and it's working. So Chris, also, you said there's other things.
Yeah.
So where should we start?
For creating attribute rules, do you have to do this before publishing the feature service?
Amanda, yes, because an attribute rule is part of the geodatabase. It's not part of the project. It's the geodatabase. So that if you wish to go and publish attribute rules, you have to do it, and you have to create them and put them in the data before you publish it. They are part of the publishing, which is interesting because that means that if you work on the web, it will automatically go and calculate through. It will automatically do this calculation no matter what technology you're using, because that's part of the database. All right. If you would, but that also means that if you want to go and change them, you have to stop the service, not take it down. You just stop sharing the service, make the change, and then reshare the service out. And that new attribute rule will work. So Lee is also asking, is the area calculation scale dependent? You see different results at different scales. Yeah, that's one of the interesting things about this, Lee, is that when you use that arcade function against the geometry, there is a little bit of scale dependency on there, to the point where if I know that I'm going to go and publish something to the web or something that has a different projection on it, instead of calculating, or instead of using the arcade geometry function, I'll go and perform a rate calculation against the square footage. I'll calculate that by the number of acres. I'll divide the number of square feet by 43,560 to give me an acreage calculation on it. But you do want to be aware of that these area calculations in arcade are dependent upon scale dependency and depending upon projection. So that if you take something and move it up to Web Mercator, it's going to calculate it in Web Mercator. I've actually gone and done some scripting where it actually goes and calculates the difference between Web Mercator and the state plane, and it's an approximate area that's returned. And I do this when I'm going to go and intersect against, for example, soils and wetlands and things like that for a pop-up. So you just want to be aware of that the arcade geometry is subject to scale and projection information. Okay, is that it? We got anything else?
That's all for now.
Okay. All right. So I've gone and I've calculated this so that every single time I make a polygon, it goes and tells me what subdivision I'm in, and it goes and automatically calculates the stated area on here. Let's go and do this a little bit more, just to sort of demonstrate here. If I go in and create something here, here it is. It turns out that they have these geometries, which are really section township range that they're calculating against, and it's calculating that. However, if I go in here, because I set it up so that when I trigger my attribute rule, it's going to trigger it, not just the insert, not when I create it, but anytime I make any modification to the geometry. So if I go and change that geometry, if you watch, the stated area field will automatically change. Got it? So that when you're making a transition, and I'll make this as just a generalized statement, when you're making a transition from the older technology, older ArcMap technology, into ArcGIS Pro technology, you want to take a little bit of time to take advantage of these changes that occur. If you're coming from ArcMap and specifically parcels in ArcMap and coming into ArcGIS Pro, there's a transition from Kogo fields in ArcMap being string fields into ArcGIS Pro. They are number fields, again, because they do calculations on them. You wanted to learn how to go and do that, or you want to get a consultant who understands how to do that for you. You also want to understand that sometimes when you make submittals to the Department of Revenue, are they going to accept those number values, or are you going to have to create additional auxiliary fields to comply with the DOR? It's interesting. I'm going to make a presentation at the Seven Hills Regional User Conference it's a virtual conference out of the Tallahassee group. on how do you design a cadastre that's Florida Department of Revenue compliant. And we're going to talk about things like that. Then we're going to, again, getting back to my original thought, when you make this transition into new technology, you want to go and understand all of the things that you can take advantage of. You can take advantage of topology or attribute rules so that you go and have as much automatically calculated for you as possible. That the editors don't have to focus as much on attribution, and they can focus more on doing their work on here. Let's do one more attribute rule to show you an intersection, to show you how easy it is to go and modify that. And let's discard all this. We don't care about that. All right. So we're going to create a new rule. And if we look here at the PLSS section polygon, just to see it, it actually has a name field, which has, in most cases, it has a township and a range, or it might just have the section number in here. But it is called, let's go in here, let's look at it. The actual source on here, it is PLSS _ sections. So what I'm going to do is I'm going to go in here to my tax polygon, and I'm going to go and create a new attribute rule. This new attribute rule is going to calculate the section in which this is located. And we're going to put that in the section field. Again, we're going to go in here, and I'm going to cheat, and I'm going to bring that intersection script up again. This time, I'm going to change the layer that we're going to intersect, PLSS _ sections, and we're going to pull out the name field on here. It is correct now. One of the benefits of understanding the new technology and understanding how to use Arcade is I can reuse code all over the place. As if I set it up correctly so that all I have to do is make a couple little modifications on where these things are pointing, I can use this same code, and it will now go and calculate for me the section in which this is located. And I'm going to do that for when I first create it, and I might as well do it on when I update it. All right, let me go and save this. So I will go and warn you about something, and maybe well, I've got some time here. We'll do this beforehand. There are times when you should use these intersect functions in Arcade, and times when maybe it's not the smartest thing to do because they are somewhat expensive. Expensive meaning takes a little bit of time to execute sometimes. When you're doing this one-off, you never see it. For example, if I were to go and make an intersect function against a label, it would actually take some time to go and do. So let's try this again. If I go in here and I go and do this, it's calculated that this is located in section 23. Here's the subdivision it's in. Here's the acreage on here. Let's go to a real subdivision here so we can see this. And here is this new parcel, section 30, township, or my subdivision is here and my area is here. When you think about this, you can actually begin going and doing and combining this code into multiple things. So I'm possibly, and recently did this for one of our clients. Their parcel identifier is a combination of a series of strings: section, township, range in which it's located, the municipality in which it's located, the subdivision, the block, and then a number. What we're doing is we're actually going and calculating all of that first, I think it's 12 values of their parcel ID for them, so that when they first create it, it goes and does that intersection. It sort of pre-populates it, and then all you have to do is take and automatically go and number what remains on that parcel ID. Once you learn how to use Arcade, you can go and string these together and show you how to do it. All right. Any other questions about this intersect before we move into just labeling and sort of go on and look at any other things there? Again, you just want to be aware that these can be a little bit expensive. So let me turn on, let's look at my label properties for, look and see, I think I have the full pin being shown here. So this full pin, this is using Arcade for my label expression. And it's going to go and give me that label expression. I should probably go and check and make sure that it's going to go and do the full pin every time. There it is there. So if I were to go and tell it, go and put something else in here, go make sure, and there, okay. Line, not a new line, there we go. If I were to go and put in an expression here for Arcade, it would take, for Arcade intersecting, it would take a very long time to go and do this, because every single one of these polygons before it goes and displays has to calculate that intersection. So it's not a very good thing to do. Rather, you want to be judicious about it and understand what costs and what doesn't cost. One more thing here. Let's go and just do this. That's the picture. Let's go and round this to 2. And let's put some text afterwards. Here, let's go and test this. It looks good. So it should now give us the parcel ID and the acreage rounded to 2 decimal places, rounded and trimmed to 2 decimal places, with the text string of AC, open parens, S, close parens. Arcade labeling expressions, really powerful. Let's go and do one more thing here. I know we only have 15 minutes. We have less than 15 minutes. Let's go ahead and create a pop-up. All right. Create a pop-up, and on here, put some text in here. Let's modify this text. All right. And let's write an expression. Let's write a new expression, and we'll call this expression sub. And you know what we're going to do? We're going to go and cheat again. And here, this was called subdivisions, and this was called name, right? And then here one more time. The expressions are where it is here. So what this is going to do is just going to go, and every time I do a pop-up, it's just going to say that this parcel is going to put in place the name field located in a subdivision. That's it. All right. So now when I do a pop-up, well, I should probably turn on my pop-ups. I'm going to say this parcel is located in that subdivision. So again, you can use these intersect functions a couple of different ways. You can use them to calculate things. You can use them for pop-ups in here. You can use them in a lot of different ways. And it's not just in Pro. You can use it in ArcGIS Online and others. You do want to, however, know what cost is associated with all of this. All right. Are there any other questions in here before I go and finish this out?
Nothing in the chat at the moment.
All right, then let's go ahead and close out this workshop and transition into office hours. So thank you all for attending.
Thanks for attending, and we hope you enjoy this workshop. If you have questions, would like some more details about anything we discussed during this workshop, or if you or anyone at your organization would like information about training, support, or ways in which we can help you with your GIS needs, please contact me at frank@pandaconsulting.com or call me at 561-691-3277, and we can discuss how we can help you with your needs.